An interaction between two bodies, a push or a pull, is called a force. If you pull on a rope that's attached to a crate, you create a tension in the rope that pulls the crate. When a skydiver is falling through the air, Earth is exerting a downward pull called gravitational force. And the air exerts an upward force called air resistance. When you stand on the floor provides an upward supporting force called normal force. In 1687, Isaac Newton published his 3 laws of motion. Newton's first law says that an object will continue in a state of motion unless compelled to change by a net force impressed upon it. That is, unless an unbalanced force acts on an object, the object's velocity will not change. If the object is at rest, then it will stay at rest, and if it is moving, then it will continue to move at a constant speed in a straight line. Newton's second law predicts what will happen when a net force does act on an object. The object's velocity will change. The object will accelerate. More precisely, it says that its acceleration, a, will be directly proportional to the strength of the total, or net force, and inversely proportional to the object's mass. This is the most important equation in mechanics. Newton's third law is commonly remembered as, to every action there is an equal but opposite reaction. More precisely, if object 1 exerts a force on object 2, then object 2 exerts a force on object 1, equal in strength but opposite in direction. These two forces are called an action-reaction pair. Now let's apply Newton's laws of motion to solve a forces problem. Let's say a crate of mass 20 kilograms is sliding across a wooden floor. The coefficient of kinetic friction between the crate and the floor is 0.3. So what we have is m equals 20 kilograms and mu k equals 0.3. The first thing we have to do is draw a free body diagram. Let's start with gravity. So this would be exerting a downward force on the crate, and we label that as mg, so the mass times gravity. According to Newton's third law, to every action there is an equal but opposite reaction, so this must mean that there is an upward force exerted upon the crate as well. And because it's on a floor, this is normal force. The problem also states that the crate is sliding across a wooden floor. Let's just assume that it's sliding towards the right. We call this F. So we know that there should be another force acting in the other direction, and this would be friction. And the problem states that this friction is kinetic. Now we have to use Newton's second law, F equals ma. Let's look at the y-axis. Gravity is pulling downward, so I'll call this negative, and normal force is going upward, so I'm going to call that positive. So I would write N minus mg, the sum of the forces in the y-axis, equals to ma. And because these two forces are in opposite directions, there's no acceleration because it's not moving, because they cancel out. So that makes everything on the right side of the equation equal to 0. Now we can rearrange and say that normal force is equal to mg. With this information, we can solve for what normal force equals to. We know that the mass is 20 kilograms, and gravity is 10 meters per second squared. So the normal force would be equal to 200 newtons. Using this, we can solve for the kinetic friction. Friction is equal to mu times normal force. In this case, it's 0.3 times 200 newtons. And we get 60 newtons. Now let's say the crate is being pulled by a force of 90 newtons, parallel to the floor. Let's solve for the acceleration of the crate. Again, we're going to start off with Newton's second law, F equals ma. And in the x direction, our forces are F. We're saying that the right direction is positive. and left is negative, so minus friction equals ma. The problem gives us the value of F, so let's substitute those values in, 90 newtons, and we just solve for friction. So minus 60 newtons, we get 30 newtons equals ma. Now we already know the value of the mass, so let's substitute in for that value. 30 newtons equals 20 kilograms times acceleration. And from there we can solve for acceleration, so we get A equals 1.5 meters per second squared. So there you have it. We just applied Newton's laws of motion to solve two simple but very fundamental forces problems.